review from Friday. We had been working on taking a look at what a parabola was, what a quadratic function was. And we said that a quadratic function was any equation basically that has a squared term in it.
We did.
We did. We're going to not. It gives a basic U shape. And what we then did is we went through and identified that each one has a quadratic term, a linear term, and a constant term. And there's labels. We did an example and showed that if you have a function, you can identify the quadratic term, the linear term, and the constant term. Okay. After that, we said sometimes they're not in the right form, so they have to be simplified. And by simplifying it, we mean we multiply that out, simplify it, and once it's simplified, you can identify the quadratic, the linear, and the constant term. Okay, now the quadratic term is the key piece that means your graph is going to make that parabolic shape. In other words, like a U, rather than a straight line. And then what we began to do is we simplified another one. And when we simplified another one, we found that sometimes that middle term will drop out. And it's okay if the linear term or the constant term is 0. But you can't have a quadratic equation if you don't have an x squared term. Okay, so there has to be an x squared term in it. You can have a 0 linear, you can have a 0 constant. And then we began to go through the process of graphing them. Okay? We said that if you had an equation, just like you used to do with linear ones, you could plug in values for x, and you could solve them. This is chapter 6. I know you were out last week, but chapter 6. You could plug in those x values, find the y values, and plot the points, and we found that a parabola has a basic shape that looks somewhat like a U. Some people argue that they thought it looked more like a V, but it's definitely not straight on the bottom. It does have a curve on the bottom, so if you want to call it a U or a V, that's up to you, but really the real name for it is a parabola. Okay, so the real name for that shape and that pattern is a parabola. We then did another example. Once again, plugging in the numbers. And when you plug in those numbers, now this is the long way about doing it, so today we're going to start taking a little look at what your calculator can do to help you. Okay, and we can plot points and make a graph like that. So that's where we stopped. And so now we need to move along. I'm going to show you an example of 3 different parabolas. Okay? Each one of them, notice I don't have very many details in here because I'm focusing on those points that I have labeled on here. What do you notice about all these points that I have labeled on these parabolas?
They're at the base.
They're at the... How did you put it? At the center? Okay, that makes good sense.
The middle of the line.
The bottom or
the furthest point away.
The top, they're either at what we call the minimum or the maximum. Okay, they're at either the top or the bottom. They're the points where the parabola turns around. The ones at the bottom would be called minimum. And the one at the top will be called maximum. Okay, because maximum means the most, and minimum means the least. So for this point in your notes, all you have to do is, you don't even have to draw all 3 of these necessarily, but just make a quick little note that you have minimum means the bottom, maximum is the top. Now there's another name for this that we're going to get for that specific point, but it is the turnaround point on that of your parabola. Okay, so the x squared term means that we're going to have that U type of shape. It might be facing upward, it might be facing downward. It will have either a minimum, a bottom point, or a maximum as a top point. Okay, I'm going to keep those same three graphs so you don't have to redraw them, but we're going to add a little bit. Okay, the name of that point is called the vertex. The name of the point is called the vertex. Now in geometry, it's the corners in a where two lines meet to make an angle. Okay, so it could be in a possible a polygon or something like that. But here it's actually in this parabola. It's the point where everything to one side ends up going the other direction than it does on the other side. So it's the turnaround point called the vertex. So on this particular group, we're going to identify the vertex for each parabola. Okay, this should be super, super, super simple. Okay, what's the vertex for this parabola? Good, -4, -3. Julia?
Our parabola is always going to be symmetrical.
They will be, yes. And we're going to talk about that in a minute. The vertex here is going to be
2, 0.
2, 0. So that specific point is labeled the vertex. And when you take your test, your quiz, you're going to be asked in every parabola, almost every parabola, to identify the vertex. In your calculator, they'll call it a maximum or a minimum. So what's my vertex here?
-2, 5.
-2, 5. Vertex is -2, 5. So if you're asked to identify the vertex and it's already drawn and given, you can actually see it on the graph where it's labeled, then that makes it super easy for you. Now, you may have to draw the graph first in order to find them. So it's not always going to be quite as simple as I just put it, but once you have the graph drawn, it's certainly that simple. Okay, any questions so far? Alright, so this took me much more time to actually type out than actually explain it. Parabolas also have an invisible line that divides it into two identical parts. Here's your symmetry, Julia. Okay, every parabola is what we call symmetric. So if you drew a line down the center of any parabola, you could fold that parabola over and it would be a mirror image of each other. Okay, so what we need to be able to do is we need to be able to identify the lines of symmetry. Now this is a little bit harder, but not much. It's not the line of symmetry here. I'm gonna draw it first. We're gonna make it a dashed line.
Is it an equation or is it an equation or a number?
It's an equation. So I'm gonna draw on the line of symmetry. The line of symmetry goes through that dot. There it is. So that line of symmetry. Okay, yeah. Pretend that the parabola is drawn perfectly because it's not. Okay, that's actually better than any year that I've ever drawn them because I have the technology, but it's still not great. So we have this. This is the one that cuts the parabola into two equal pieces. It has an equation. What is the equation for this vertical line that goes through this point?
-3.
-3, but it's not just -3. It's x equals -3. It is an equation, not -3. Which one is it? X equals?
-4.
-4. X, the x coordinate. The x coordinate tells you the equation for the line. That's the line of symmetry. Y is the y coordinate's -3, but the x coordinate, all of the x's along here are -4. So your line of symmetry will always be in an x equals form. Okay, the line of symmetry will always be x equals, and it will be the x coordinate of your vertex. So once you find your vertex, finding the line of symmetry is super easy. So here we said this is the vertex. I'm going to sketch in the line of symmetry, and you're going to think about what that line of symmetry, the equation would be. This one will be what?
X equals 2.
X equals 2. If you do not write the x equals and you just write 2, you'll get points off. Because it's probably all of them, because it's the actual equation.
What about line of symmetry?
The line of symmetry is x equals 2. The line of symmetry is not 2. Because a line is actually, it's an equation. So x equals 2. This line of symmetry, I do want you to be able to sketch them in. So, you know, this one, x is negative 2. It's always this first number. Yes.
That goes like a C.
Sideways? It can have that shape. These are technically functions, which means that the vertical line test passes. If you have a C, it's not a function anymore, but it behaves like everything about it is like a parabola, but the x's and y's are switched. So on that one, you'd have x equals something times y squared plus something times y. So keep that in mind. But we're gonna put that on hold for a really, really, really long time. So that's okay. All right, now. Yesterday, Friday, we had been working on doing some graphing. I want to show you some tricks with your calculator for graphing. If you're going to do graphing by ordered pairs, we can actually use your calculator to show a table of values, and then later I'm going to show you some other things. We won't do the table of values much, but I want you to be able to do it. So let's, we can use our calculator to help graph a parabola using points. So let's take a look at the equation y equals x squared minus 6x plus 5. Okay, and we're gonna use this as an example, and we're gonna be able to plot some points. I'm just gonna do it very roughly, but I want you to be able to see there's a big shortcut rather than plugging in each one. So I want you to take your calculator. Let's follow the steps together. Press y equals.
Hold on.
Okay, upper left-hand corner. Blue button, upper left-hand corner. If there are equations already in your calculator under y equals, you need to clear them out. So be clear. If there's anything left under y equals, so you should. So press y equals. Then enter your equation. You remember where the X button is? X is down and to the right of
Alpha.
well, it's actually just right, one to the right of alpha. There's an X, so you're going to put in X, then push your squared button, minus 6X plus 5. Okay, I'm going to walk around and just check and make sure that you all do that. Put in
What's the X?
X squared minus 6X plus 5. Here's the X right there. So X squared minus 6X minus 6X plus 5. X squared. X right here.
Press.
And then do
And then it goes to the
Squared.
table.
square.
Okay, you're in good shape.
Are you doing
X squared. Good job. All right.
Where do you put it?
All right. Is there anybody who doesn't have that loaded in yet?
Minus 6x.
Plus 5.
Plus 5. Whoa.
Okay. Now,
What are we doing?
What I want you now to do,
You'll find out.
we're at step 2. Push second and graph, and you'll notice the word table is right above that. So it says table, second, graph, and it shows you a table. And you'll have some X values and some Y values.
What is the third column for?
This one.
Don't worry about the third column.
My pen's not working.
Okay, so we've got that now. And what you can see is this is an entire list of points for you. And as you start to scroll down, you'll notice that in the Y column, there is a point where the numbers start repeating on either side of that number. Okay, so scroll down until you find a number, and the number above it and below it are the same number. Okay, so scroll around. You're way far. Keep going. Yeah, so you're going to scroll until you find in the Y column that you have the same number above and below that number.
How long do you
Nope.
have to
You have a lot of scrolling.
Equations in here that need to be cleared out. It's confusing.
So now,
Okay, I'm gonna like x equals 71.
Wait,
go down. You're way
I
far
don't
off.
think
Broke it.
Anderson
Look like
would
you go back.
it's so fast my entire life.
No.
Like,
What?
I look like
Okay, so
Really
Dumb.
you're way too far. You should be down
I'm at
here.
94, so.
You should be down near 0. Okay.
It's not going down.
Oh, you don't have to go far. You don't have to go far.
Okay, so
Oh, we're looking on the Y side.
what number do you notice in the Y column that has the same number above and below it?
I can't do this.
Which one?
Where are you at? What are you looking at? I can't find this. So flip it, confess.
Keep going. You should be down 0. So use your arrow.
Wait, there's a 0 here, 0 there.
Okay, and then 131.
Oh,
Why?
Bring it.
Shut up, maybe I was gonna say it.
This is it, right? Right there.
Oh, I want a little bit bigger.
-3.
I
know what you
Let me blank out my left. No, be blind up.
What about table?
Not blind, but you
I didn't.
can't see. Oh, it's -4.
All right,
I wasn't here on time.
What
Um,
number is it? 'Cause I can't find it.
I got
Now,
You didn't have to go anywhere.
-4, when you look and you see in the Y column -4, notice that -3 is above it and -3 is below it. These are all ordered pairs.
Nope.
So
No, it's not.
when you put that in the middle of your screen,
Oh, that's
X and Y, we notice that -4 goes with what number? 3. So we have 3 -4. We have 2 -3. We have 4 -3. And then 1 is paired up with 0. And 5 is paired up with 0.
What?
Wait, I what? Wait.
Yeah.
How
Yep.
5 is paired up with 0.
Coin.
So what we notice when you're using your arrow keys, you find out that there's a point where you've got the same number above and below. Like I said, we're only going to do this like once because there's other methods that we're going to use. But I wanted you to see that the table of values exists. And so what we can do then, if you don't want to actually plug in each individual value, you can use this method to get a table of values, and then you can plot the points. So 1, 0 would go like here, and 2, -3. Okay, I'm avoiding that for a reason for right now. And then 3, -4. But we do need to be able to do this by hand for now, and I have a real good purpose for that. And you plot that point, and then 5, 0 would be here, and then you'd sketch in your parabola. That makes a U shape. And so this is a method that you can use to find a bunch of of values, but if you're finding that that method isn't that great, we're going to do something better that tells you more information. I just wanted you to know that the table existed.
Wait, how do you plot the points though?
Wait,
How do you
Take them, you have a list of ordered pairs.
You
1, 0. You plot the points not on your calculator, I'm talking about on paper. And 2, -3, and 3, -4, and 4, -3. This goes back to what I was telling you last week with our graphing, when we were graphing by hand. Your calculator will give you a table,
And then you would have to put it.
so you understand that rather than taking each one of these individual, plugging it in and solving for this one, your calculator can give you a table of values. That's the only reason I put this on here, if you wanted to, so that you could find the table of values in an alternate way. But as I said, we're going to be looking for a lot more information, so we're going to have to use the calculator more aggressively than this. So if you didn't write all this stuff down,
Aggressive.
I'm not going to wait for you to catch up because we're probably not going to use it again. So don't worry about this.
I am.
I wanted you to know that it exists.
I'm gonna use it.
All right, let's move on.
Wait, I have a question.
Yes.
Wait, can you go back to the last slide?
I said I wasn't going to wait, but what's your quick question?
Wait, why do we plot it? We have the vertex.
Because the vertex is not the only important thing. I wanted people to be able to
Oh, so you're just
practice
saying so you're saying like on oh my god.
on graph paper.
No, I mean like but for like homework and just quiz,
For
like that's
homework?
what we have to do.
Rewrite that.
This is a method that you can use, but it's not going to end up being the most efficient. But it goes along with our initial introduction saying that it's a list of ordered pairs. So one thing that you guys have to understand is that this is not just some random shape, it shows all the solutions to this equation. So this is, if you took all the time, and some of you were scrolling for a really long time, to plug in all those numbers, all those ordered pairs would be on your parabola. Okay, sometimes people lose sight of what really is going on when you're graphing equations. You're showing all of the possible solutions that will make this true. So that's really the only reason I stuck this in here, was to kind of try and make that point. But we have some other things that we need to talk about with parabolas, so we're going to move on. Let's make sure you write down everything. Parabolas may or may not cross the x-axis. Sometimes they'll cross the x-axis and sometimes they will not. The x-coordinates of the points where they cross the y-axis. Wait. The x-coordinates of the points where they cross this, should say x, cross the x-axis are called the zeros of the parabolas. Yeah, definitely write this down. This is important. This is the definition of something called a zero, not as a number, but as a definition. It's called a zero. It's also called a root. Okay?
Yes.
So,
Oh my god.
parabolas may or may not cross the x-axis. If they do, the x-coordinates of the points where they intersect it are called the zeros. You could also call them roots. You could also call them solutions. Well, you're going to need to know all of them. I'm just introducing the terms one at a time, but they're all synonyms. Luke.
Why is there something crossed out before the word X?
Because I accidentally wrote y-axis, but it's the x-axis.
Okay.
They intersect the x-axis.
What's today's date?
They're called the zeros. All right, so notice I didn't put the vertex in these because except for this one, I didn't put the vertex in because I'm interested in identifying the zeros or roots. There, I put the other word in. You can add that in. It's like a little arrow. The zeros or the roots of the parabola. So we want to name the zeros for each parabola. Okay, so, or the roots. You may see the term zeros, you're more likely to see the term roots. So the zeros of this parabola are blank or blank. The zeros are what, Alexis? Go ahead.
I mean, excuse me, deflagellated.
-5 is the x-coordinate here.
Don't be
So
sarcastic.
the zero of this zero is -5, and the other zero is 1. They call them the zeros because look at the y-coordinate. What are they? Zeros. Okay? So the y-coordinates are zeros, so they call the x-coordinate that goes with them the zeros. Okay? Honestly, I don't like the name of them because it's confusing because it makes you think of the numbers. It just... Roots and solutions are also worked for. But yeah, but they do call them the zeros in a lot of math books. So because the y-coordinate is 0, the x-coordinate is the x-coordinate. So the zeros of this one are -5 or 1. How many zeros does this one have?
1.
This one has 1 0.
Yeah.
And the 0 in this case is
-3.
-3.
Whoa, get this. I understand.
What about
where it passes through the y-axis?
Does it happen?
Where it crosses through the y-axis is the y-intercept, but we haven't got to that yet. It's also important. But believe it or not, the most important thing in these are actually the zeros. The roots. Because these are going to be our solutions to certain equations. Okay, so the last one. How many zeros are here?
0.
0. So there are no zeros. No zeros. It's the same as saying no solution. There's no zeros, there's no roots. Okay? Because we're going to use these things later down the road. Okay, so does everybody have that down? No? Okay, let's make sure you get them down. This is the ordered pair, -5, 0. This is 1, 0. So the zeros are -5 or 1. This only touches the x-axis once. So there's 1, 0, and it's -3. This doesn't touch it at all. There's no zeros. It doesn't cross the x-axis. And what is coming next is going to be really explaining what I want you to do when you're going to be graphing the equations with your calculator, because Grace, when you graph an equation on your calculator, you're going to need to find the zeros, the axis of symmetry, the maximum or the minimum, and the y-intercept. So there are ways to make your calculator give you all that information, and I'm going to go over that with you. It will take us quite a while to do that. But that's what we're coming up to next. So make sure you've got your calculator handy. We will go step by step. It will take longer for you to write the directions than to do this, but you're going to have to make yourself practice it. It's a very, very, very fast process if you practice it. If not, if you have to read your notes for every step when you get to the test or quiz, there's no way you're going to have time to do the whole thing. You have to practice it when you do the homework so that you can get good at making this calculator do what you need it to do. So it's going to be very important. We're going to, this section, and you'll probably need quite a bit of room for this. How to use the calculator to get the key parts to make the graph of a parabola. There are 4 key parts. The vertex, which we talked about what it was, the line of symmetry, the roots, and the y-intercepts. And I'm going to walk you through each part. so that you can do this. Okay, so. Okay, alright, sorry. Sorry. Actually, let me just really quickly peek at something real quick. The roots are the zeros, yes. Alright, so let's take a look at an example. We were going to go through an example together. Okay,
What just
now,
happened?
here's our example. Now, what we see here is our instructions would say graph the equation y equals 3x squared minus 12x plus 1. Okay? This is like, this starts the key slide. You have to write down every word now. So,
No, week. Maybe this week. Not even
graph the equation. So, this is going to be a pretty long process. So we're going to graph that equation. The first thing you need to do is enter it into your calculator. There is a typo here, so I want to fix this quickly.
That's why I'm on the other crap.
So, what you need to do, you might use Zoom 0 later, yeah.
Okay, let's
But there is a Zoom 0, yes. But we're not. Okay, that actually we will use that, but for right now, here we go. So put this in your. You have the instructions. Make sure you write down the instructions. And I want you to put that in your calculator.
enter into
Y equals.
the y equals.
Yep. So enter it in the calculator. Push y equals like we did before.
Enter.
Y equals, and you see the equation. Put in 3x squared minus 12x plus 1.
Zoom 6.
And we're going to push Zoom 6.
I remember Zoom 6.
And when you do that, what do you notice?
It quits.
Zoom 6, you're going to have a little missing piece on the bottom of your parabola, aren't you?
Yeah.
What did I do wrong?
Let's see. Let's figure out. Let's make sure everybody's up with this on this.
Oh, now I lost my graph. You ready? Watch
Oh
this.
yeah, no, it's not it.
Let's see.
I plugged it in.
3x squared minus 12x plus 1. Now push Zoom 6.
And if I do Zoom 6, watch, it quits. It's not missing one.
Invalid dimensions.
Do I have to
Why
remove
is it
those?
doing that? Let's check your snap plots.
Somebody got a little like the view to New York.
Oh, there we go. We need to turn the plots off. If you have your plots on, turn your plots off.
Turn them off.
If you're having a problem, if your calculator isn't showing you your graph, make sure your plots are off.
No.
Okay, you're good.
Great.
Oh, I did Zoom standard. How do
There
you-
we go.
I forget. I'm super.
Now we can find it.
How do you adjust when you adjust it and you don't want to put it back?
Okay.
Okay.
Okay,
Oh,
now
crap. I get it.
here we go. We do need to adjust this because we're missing the bottom of our parabola, right? So it says adjust if needed. What needs to be a little bit, where do we need a little bit more room?
The bottom.
The bottom. So you need to push your window button. Notice on the notes here I say adjust the window, so you need to push the window button.
-25.
And where it says window, we notice that our Y minimum is -10. We should adjust that a little bit, right? Let's bring it down to -15. You only need a little bit more room. So then push graph. Instead of Zoom 6, push graph.
I see it.
Still graph.
You gotta wait for it to be alright.
It's still part of step 2. Because you need to adjust your window so that you see your nice parabola. If you don't see a nice view, it's not going to work for you.
Right here.
With the love of Jesus.
Okay?
Amen.
So we adjusted the window. You push the graph button, and now you should have a U that looks a little better because you can see the whole thing. Push your window button
Adjust window.
and change your Y
So underline
minimum to -50. There you go. Now you can see it. Okay? Is there anybody who's not on this screen right here? You should see. Right now, I want you to have your parabola showing. Okay, so push your window button. Or not. Now, here's the window. Or don't room down at the
I
bottom.
never got that until like
You got it?
when I was younger.
Yeah, I got it.
And I
Everybody
was
got
like,
it?
oh,
Okay, good.
that's what that was about.
My calculator was my only friend.
Got it?
Jesus is Lord. Jesus.
Okay. All right. So
Did you say you want to be so cool?
now this is gonna. It will take more time for you to write these instructions than to actually do it.
Move cursor.
And I didn't mean to put all this. I didn't mean to put this answer right here. What we are looking for, remember, I said we're looking for the vertex, the axis of symmetry, the roots, and the y-intercept. Step 3, this is how you find the vertex. Now the calculator makes you push quite a few buttons to do that, but that's why I said you have to practice. Because you're not going to read each direction every time you do this. But I did take the time to type them out.
What's second count?
Because you're going to need to at least run through the steps when you're doing your homework. If you do not practice it, you'll have the question in front of you on your test and not be able to do it.
I have a question.
Because you're going to have to practice it. Yes.
Why are there question marks?
Because there's question marks on your calculator. You'll see when we go through the steps. So for right now, you're not rewriting this part. This part was here already. But this is how we find the vertex. So write this down. Push second count. Choose 3. Min. This will make sense as you go through the process. Move the cursor left of the loop. It says left bound, hit enter. Move cursor right of the loop. It says right bound, hit enter. It says yes, hit enter, plot the ordered pair. Let's go through them one step at a time. Right, make sure, does everybody have the instruction push second count written down? Just the part that says push second count, that's the very beginning. I want you to push second count. Second, it's on the trace. Is everybody on that screen where it says calculate? Okay, you need to get there. Okay? Yes.
Last one was over and you were going to send the test, right?
Yeah, I need to get this one first. We need to at least find the vertex. Second calc. Now choose 3.
Where's Tom?
So write down choose 3 that says minimum. When you saw your loop, it went down under, so you know it's a minimum, it's not a maximum. So this one we're going to choose 3. Just choose the maximum instead. So go to 3, choose minimum, hit enter. So we're right now on this step, hit enter. Oh no, we're on this step. We're not on. We're actually right here. Choose 3 minimum. And you should have a blinking cursor show up on your graph. Does everybody have a blinking cursor? It's like a little blinky dot. Yeah. On your parabola. Everybody, is there anybody not seeing a blinky dot on your parabola? Okay. Now you're going to move the cursor. In other words, that little blinky dot, so that it is down on the left side of your loop, but definitely not on the bottom. So move that little blinky dot so it's down on the left side of the loop. It doesn't really matter where, no. Just so that it's on the left side of the loop. and then you see the little thing, it says left bound on your calculator, and a little question mark. It doesn't even really matter where it is, but you need to hit enter.
Then it says right now.
And then it says right bound, so move it to the right hand side of the little loop. And then hit enter again.
Doesn't matter where.
Doesn't matter where, as long as it's to the right side of the loop. Then it says yes. For whatever reason they wanted to do that, so hit enter again. And it should say minimum 2 point and then a whole bunch of zeros and 1.
Oh, I didn't get the zeros.
And the other one should say negative 11.
I failed.
If it does not, we'll go back over this tomorrow, but this right here
I got it.
I don't know what
should be 2 negative 11. 2 negative 11. Wait, this is the one I didn't correct yet. And so you graph that, graph the ordered pair, 2 negative 11. We found the vertex, and we'll get the rest of the steps tomorrow. And if anybody didn't get to finish writing this off, then we will take care of that tomorrow.